Hello everybody, I am Professor Dr. A.K.M. Head Department of Electronics and Telecommunication Engineering, Daffodil International University. This week 12, I am going to discuss on OSPF, Open Shortest Path First, on my course Computer Networks. In these chapters, we will be discussing on the features of OSPFs, what's the advantage of this course, how these remote networks will be discovered, and there are some parts, other parts, how metrics can be calculated, we'll be discussing on in this part. Okay, what is the meaning of OSPF? Open shortest path first algorithm, actually it's a routing protocol for internet protocol or networks. It uses a link state routing algorithm and falls into the group of interior gateway protocols operating within a single autonomous systems. In this figure, you can see there are some autonomous systems and different area, but all inside the autonomous systems will be covered using same area in this figure. Use flexible metric instead of count, support VLSM, that means variable length subnetting, allow load balancing among equal cost paths because the same destination networks, the metric will be the different or same way. So the question will be asked which way should be preferable, that means the two is same. So this type of problem is called load balancing, so equal cost load balancing will be allowed in OSPF configuration. And support types of services, TOS, authenticate and root exchanges, quick convergence, and support multicast. So quick convergence also, as well as the basic parameters of OSPF, because you know the LSP plotting, because there are some features here, a lot of information will be exchanged in this topology. So convergence time should be faster is the required informations of this OSPF configuration. So that's why it is highlighted here, the quick convergence, and support of course the multicast. OSPF areas, within each area border route responsible for routing outside the area. In this figure, you can see in this figure here the area border routes, the backbone networks, internal routes, and there are some area 1, area 2 and area 3. Here is the backbone router, exactly one area is backbone networks, and backbone area contains all area border routers and possibly others. You can see there are some informations also being exchanged here in the boundary router also, and it is internal and external parts have. OSPF area types, it restricts the amount of external routing informations within an area. This is actually used when resources, especially router memory, is very limited. And there are two types of restricted areas, and stub areas and NS, SS or not so stub areas. OSPF message encapsulation. So previous session week also discussed about the frame formats of EIGRP, and this is at also data link frame header, and this IP header, and OSPF packet header, OSPF packet type is specific data, and data link frame structure Ethernet frame shown here, IP subnet, OSPF packet header, OSPF packet types. We'll be discussing little bit later about suppose what kind of packets will be considered for open shortest path first protocol. This is OSPF packet types. It is very important to calculate the information to being exchanged the information for being exchanged the informations using OSPF. These packet types will be considered, and they are having corresponding description here. Hello packet. It discovers also same as EIGRP concept here to form adjacencies. It discovers neighbors and builds adjacencies between them. Database description, you can see here, checks for database synchronization between routers. That means there is some synchronization will be needed between two consecutive routers. Link is requests specific link state records for router to router. Link state updates, it sends specifically requested link state records. Link state acknowledgements, it acknowledges the other packet types. Hello protocol, OSPF also having hello packets use hello protocol. Purpose of hello packets, discover OSPF neighbor and establish adjacencies. So also like EIGRP sends after some times, some frequent times, hello packets to form adjacencies between two consecutive routers, neighboring routers. Advertise guidelines on which routers must agree to become neighbors, used by multi-access networks to elect a designated router and a backup designated router. So in the later some slide we will be having discussed briefly about DR, that means designated router, and BDR stands for backup designated router. Hello packets, you can see here the router sends the informations hello packets after some times. OSPF hello packets actually are sent every 10 seconds on multi-access network and point-to-point serial links. And actually which routers, how these hello packets can be sent, why this router should hello packets to other, it actually recognizes the router ID. So if every router have the router ID, then all be the hello packets will be exchanged. How? The question is how router ID will be calculated. First we have to consider here the default router ID selections. The router, they have some many IP addresses in his interfaces. You can see in this figure the router, first router, there are some active interfaces, and every interfaces it has some routers. You can see here, look, imagine here if one router have some multiple IP addresses, highest IP router, highest IP will be the router ID of this particular router. So that means if one router have 3 IP addresses like 192.168.1.1, 192.168.1.2, another 192.168.1.10. So that means 192.168.1.10 is the highest IP of his interface. So this 192.168.1.10 IP will be the router ID of this particular router. So in this way every router will be found. The router ID will be found in every router in this way. So in this way very easily router ID can be calculated. Now the one router will send the information to other router using this router ID. So matching interface values for two routers to form an adjacency, hello interval, dead interval, network type, hello interval, dead interval, network type. As I earlier said, there are some 10 seconds hello interval and 3 times of the hello intervals, that means 30 seconds will be counted for hold down timings. OSPF link state updates, purpose of a link state updates, LSU used to deliver link state advertisements. You can see here, purpose of a link state advertisements contains information about neighbors and path costs, and you can see the acronyms LSA and LSU are often used interchangeably, and so as LSU contains one or more LSS. LSS contains route information for destination networks. LSA specifies, and also the CCNP, if you see in the figure, there are a lot of informations will be discussed there. OSPF algorithms, OSPF router builds and maintain link state database contains LSA received from the other routers, and it is actually used Dijkstra shortest path algorithm. The question is how metric or how the destination network is being calculated in OSPF. OSPF uses shortest path first algorithm and Dijkstra shortest path minimal algorithm, and it is link state information. That means we know the calculations we will see in the later section that there are some metric calculations, there are default values, default parameters, default bandwidth, reference bandwidth, and the link bandwidth will be divided by reference bandwidth, and this is the metric of each link. So from one router to another routers through this link, where the metric is lower, it will get higher priority. Correspondingly, we can say the bandwidth is higher. So the RIP, it was like this only, the minimum hop. You can see there are highest bandwidth or lowest bandwidth, it doesn't matter. Where the minimum hop, RIP was calculated, the route was calculated by minimum hop. And EIGRP, bandwidth, load, delay, reliability used to make the metric calculations. But for shortest path first algorithm, only reference bandwidth and link bandwidth will be divided and metric will be calculated. And from source to destination, where the metric is lower, will get highest priority. Also administrative distance here in OSPF 110, as earlier I discussed also, again I am discussing here. Administrative distance is very important, because if two routings are privileged to go to the destination networks, the question is which routing should be get preferable. So where the routing information administrative distance is lower, will get highest priority. Okay, so OSPF authentications. The purpose is to encrypt and authenticate routing information. This is an interface specific configuration. Router will only accept routing information from other routers that have been configured with the same password or authentication informations. Also in EIGRP also this is regarded OSPF packets encrypted. That means the routing informations are being exchanged from consecutive two routers will be authenticated. OSPF metric, just a little bit earlier I discussed about this. OSPF uses cost as the metric of determining the best route. You can see here the table right side, there are some parameters here. Okay, so very easily you can say this is the default here. The default reference bandwidth of EIGRP was 10 Mbps, and for OSPF it is actually 100 Mbps. That means 10 to the power 8 Bps. OSPF uses cost as the metric for determining the best route, you can see, and the best route will have the lowest cost. Best route will have the lowest cost, that means you are dividing the value with the reference bandwidth divided by link bandwidth. If the link bandwidth is more, the ratio of this value will be less. So that's why this condensation here very clearly you can see the best route will have the lowest cost. And the cost is based on the bandwidth of an interface. And cost is calculated using the formula 10 to the power 8 divided by bandwidth. You can see from here, as earlier discussed here, the 10 to the power 8 divided by bandwidth. The reference bandwidth is 100 Mbps, megabit per second, and can be modified using autocost reference bandwidth command. And also directly we can write the command bandwidth something values from the command line interface, as well as we can write the program autocost reference bandwidth, also IP OSPF cost we can put here. So the interface type and the cost of the link, it is calculated in the table. Fast Ethernet you can see, again Ethernet E1 T1 also you can see, and also for 128 for kbps, 64 kbps, 56 kbps, what will be the cost of the link. Cost on a OSPF routes, cost is accumulated value from one router to next router. You can see in this figure there are three consecutive, the three routers are connected to each other, and here between every link there is some bandwidth, and so we can mention from the CLI command directly. And also if we say the value of 10 to the power 8 divided by 64, what is the value of this, then we can directly also we can put this metric value in the CLI command. So both are visible here, both are allowed here to write. So from the show IP root command we can see the output from here, we can see what is the condition of this topology. Basic OSPF configuration, you can see modifying the cost of link. Both sides of a serial link should be configured with the same bandwidth. You can see here commands used to modify bandwidth value. Bandwidth command examples here, bandwidth suppose from the CLI command directly you can write bandwidth 64. So if it is 128 of this link bandwidth, if you write bandwidth 64, automatically the bandwidth of the link will be changed. and corresponding metric also you can manually write. If you go IP OSPF cost command allows you to directly specify interface cost. From this interface serial you can write IP OSPF cost 1562. If you think 10 to the power 8 divided by 64 is 1562, so you can write either bandwidth 64, also you can write the metric IP OSPF cost 1562. Basic OSPF configurations, the difference between bandwidth command and the IP OSPF command. IP OSPF command sets cost of a specific value. Link cost is calculated also by bandwidth command. Here left side and right side you can see, if you change the bandwidth of the links, suppose 64, 256 or something, and the right side corresponding cost command, that means what's the definitions from the bandwidth 10 to the power 8 divided by the bandwidth, there will be some values. In the right side you can change the information also using right IP OSPF cost 15 like something, some values or like this. Neighboring broadcast networks also you can see in the broadcast domains, you can see that there is a switch and there is some routers here, and each router has some informations, and every links has sub router ID loopback addresses, first address and highest calls of the calls. So as earliest it was like this, it had to be mentioned also the router ID selections first. Again I will repeat here, the first router ID, if one router has the loopback interface, this loopback interface IP will be get highest priority to be the router ID. If there is no loopback, then highest router, the highest IP will be considered for router ID. So OSPF router types here, you can say the one is DR, one is BDR, one is other DR others. So why these communications here? Because there are in broadcast domains one switch can connect more than one routers or some routers. This is multi-access broadcast part, and if the information is exchanged to each other in broadcast domains, so there will be too much traffic, there will be some problems. So how can we to remedy the situations from the problem? So we can mention one is DR, one is BDR, and other one is DR others. Here we can see the challenges in multi-access networks. OSPF defines 5 network types here. One is point to point, one is broadcast multi-access, non-broadcast multi-access, point to multi-point virtual links. And you can see in this figure, this is the mesh networks, like every router is connected to each other, because if one router sends the information, all neighboring routers will be received, all informations will be received by neighboring routers. In this figure you can see here, please, you can see, you can concentrate here, all routers are associated to each other, and it is multiple adjacencies and extensible as flooding. The question is, the formula is, if 1, 2, 3, 4, 5 routers are associated to each other, so n into n minus 1 divided by 2, so 5 into 4 divided by 2, that means the 5, 4, 2, so that means some connections, adjacencies, 10 adjacencies. In the same, you can see if 100 routers are connected to each other, so that means 4950 adjacencies will be communicated here. The problem is to solve this problem. So if one router sends the informations to other routers, if the receiving routers try to send the acknowledgements, so what will be happen in the traffic is too much load in the traffic. So what is the solutions? So solution is, we can consider one is DR, one is BDR, and it is selected, and the question is how DR and BDR, what is the roles of DR and BDR? So that means all other routers, DR others, the information will be sent to the DR and BDR, and DR will take the responsibilities to send the information to other routers, and BDR is standby. If in case if DR fails, then BDR can take part of DR. So now there is no chance of collisions inside the switch or some other links, because it is not send the information randomly, because DR now, if one router want to send the information, he can't send the information to all other routers, because he will send only DR and BDR, and DR is taking the responsibility to send the information to other neighboring routers. So the question is how DR is and BDR is selected. Normally first I said the router, the total topology whose router has the highest IP addresses will be the router, that means DR, and second highest IP contains router, second highest IP will be the BDR, and all of others it is called DR others. The question is if the two highest IP is same, then who will be break the ties? The highest router ID of these two routers will break the tie. Highest router ID of these two routers will be the DR of this contains. So question is here how it is maintained. If one DR is selected, he will never be down. If he downs himself, or administrator can downs by force. Also for same things, BDR if it is selected, nobody can down him, or he downs himself, or the administrator manually downs himself, and other is DR. If new router is come with highest IP, he will be also be DR others. If previous DR fails, then BDR will be the DR, and next highest IP of this other DR others, so one of them will be BDR. If again the previous DR is back, then he will be DR others, because I said if one DR exists, there is no chance to down, because if he downs or if he fails himself or forcefully it is failed. OSPF multi-access networks, here we can see next highest IP router ID I said, and the highest router ID of right side you can see it is coming, and the DR with the highest OSPF interface priority, the router with the second highest OSPF of BDR, and if OSPF interface priority equal, the highest router ID used to break the tie. I said also, I explained little bit about this. So students, thank you very much for these sections. We will be discussing on next session or next week, when you will be concentrated in this assembly here. Thank you very much.